Welcome to a Blue Collar Coder side project video where we finish off one of those pesky side projects I got lingering around. And this one is actually pretty cool. This is a GPU recommender app. It's mobile web and it's using Material, and it's going to allow me to type in the type of GPU that I want. Okay, let's say that I want a 3070 and I'll type that in there. And then it shows me some recommendations of similarly spec'd GPUs that then I could go and maybe find, as opposed to the 3070 that I really want. Maybe a Radeon RX 6800 is in stock instead. So you might know about Material and you might know about React, but you might not know about the recommendation engine that's going on here. So this is not an API call. I'm actually doing this right on the client using an algorithm called a KDTree. And a KDTree allows you to find the nearest neighbors of an n-dimensional point in an n-dimensional space in O log n time using a binary tree. And if that seems crazy complicated, it really isn't. If you know how to import a library, if you know how to do some array manipulation, if you know how to render the results of that array into a React app, then you'll be able to handle this. And I'll go through how a KDTree works in the context of finishing this off. All right, so let's jump back to the office and finish off my little side project and maybe find out what a good GPU is. All right, so we're back from the river and I've got the app running over here. At this point though, if you click on any of these, you'll get the same 10 recommendations, which are just the first 10 items on the list, which is not great. It's not what we want. We want to actually go and do some recommendations. So let's go over to our app and I'll give you a little bit of a walkthrough and then we'll fix it so that it actually gives us some good recommendations. All right, well, the first thing we're going to look at is gpus.ts. And this is basically the data. Now I've gone to a GPU comparison site and I've actually mined all that data, and what we got back was a ID, which is an index number for the GPU, the name of the GPU, a price if it's available, and then we've got the set of metrics that we're going to use to compare these cards by. The first is a G2D number, which is a comparison of 2D performance, and then DirectX 9, DirectX 10, DirectX 11, DirectX 12, and an overall speed number. We also have price per G3D, but we're not actually going to use that in this comparison. And then we've got a list of the comparison keys, and these are the ones that we're actually going to use to do the comparison. So if two cards have a similar G2D number, as well as a DX9 number, and so on and so forth, then that would be considered a good or close comparison. So down here in titles, we've got a map between the key and the human readable title. And then finally, we've got the actual data. So here's the 15FF card that we've been recommending because we just slice off that top 10. Now let's go take a look at the React side of the house. So starting over here on app, it's a React router-based app. It's got two routes. Currently, it's got the homepage route, which is on GPU comparison. It's on GPU comparison because it's actually deployed on GitHub Pages, and GPU comparison is the name of the project. So that's why everything's /GPU comparison /something. So this is the homepage, and then there is the comparison page, which is what you click into when you click on something on the homepage. So let's go take a look over on the homepage. And it's going to bring in the list of GPUs because it's going to go and do just a basic string search on those. That search data is held in this use state. It uses use history from React Router DOM because when you click on one of those items, it's just going to push the route to go to the comparison page. And then finally down here, we've got a Material UI text field, as well as the cards that are displayed as you type in that search term, and that's computed with this use memo up here. So this use memo has a function on it. It looks through all of those GPUs and looks to see if it matches name-wise the search parameters, and it takes this the top 20 of those. So anytime search changes in that dependency, then displayed cards is recomputed. So that's why if I type in 3070 here, this gets recomputed and these values are shown. So once you've clicked into an item, you again use that React router. So you come essentially back to app.tsx and you look at the GPU comparison page. So let's go take a look at that. So this one is going to use params from React Router to get the ID off of the route, which it does here. So it gets the ID using use params. It then finds that GPU in the list of GPUs using this use memo with a GPUs find on it, just an array find. There's also a back button on the page. We have an on back handler, which just does a history.go back. And then at the top of the page, we've got that back button, we got the GPU name, and then we've got the comparison chart. So the comparison chart is over here, and it's a bit more complex, but it basically just goes and compares these two GPUs in a 3-column layout. So let's go take a look at that. I'll go over here to the GeForce whatever 3070. And you can see at the top level, we got a single row that's got the two different names of the different cards. And then we got a list of all of those comparison items that we had from before. So let's go take a look at how that's done. Go all the way down here, we can see that we have a comparison chart that's setting up that grid layout. And then at the top, we've got an empty item for the first item. And then we've got the two different GPU names, the selected GPU, and then the one that's currently your recommended GPU. And you can change that by just simply swiping left or right. And that's managed by this really nice React swipeable library from Formidable Labs. So I'll keep going down here. So within that template, then we've got comparison keys, where it runs through all of those comparison keys, G2D, DX9, DX10, all that. And then it creates a row, essentially, for each one of them, where it's got the title. And then it's got the original value. And then it's got this comparison value component that basically gives you that really nice red up or green up or red down arrow, and then the value. And then finally, we drop in the price. So that's how all this is formatted. It's a lot of code, but it's actually not that complicated. So the really important part is over here in recommendations. And that's when we call get recommendations with the selected GPU. So the selected GPU is the one that's on the route. And what that does right now is it goes over here to this recommender and does get recommendations and gives it a GPU and says, hey, give me some GPUs back that are equivalent to that GPU. And all I do at this point is just give you the first 10 items by doing a slice, which is clearly not what we want. So what we want to do is go and bring in this static KDTree library. So it's a pretty underused library, but it's really good. So I'm going to go and do a yarn add on that. And in the meantime, let's go and take a look at what we're going to want to do with it. So first, we're going to want to go and create a set of points. So this is a 2-dimensional array, meaning we have an array of arrays. So here in this case, we're creating a bunch of different 3-dimensional points. So you've got 3 dimensions, X, Y, and Z, I guess, if you want that. And then it's an array of that. So every single item in that array needs to have that dimension to it. But the great thing about a KDTree, in particular to other nearest neighbor algorithms, is that the number of points here can be as many or as few as you want, I guess down to 1. But in this case, for example, we're going to use, let's see, 1, 2, 3, 4, 5, 6. We're going to have a 6-dimensional array because we're going to basically put, for each one of these points, the different metrics from each one of the cards. And then we create the KDTree using that 2-dimensional array. And from there, we can use the KNN method. And what KNN allows you to do is give it another point. So that's the point that's generated from the selected GPU. And then give it the number of results that you want that are the nearest neighbors. And you can also specify max distance, but we're not going to do that. Okay, so that worked. We got our static KDTree now, and I know that it's not a TypeScript library, so I'm going to go and do yarn add at types static KDTree, which is what you do if you know that you don't have TypeScript types built into the library. Oftentimes, folks will have independently contributed a type at types slash and then the library name, and that will have the types for you. Unfortunately, in this case, it is a very small library, so we still don't have typings on at types. So what I'm going to do instead is but that's okay. There's actually a fix for that. So I'll just start this up and get rid of this. And in the meantime, I'm going to go and create a new file in here called types.d.ts. And in there, I can essentially declare the types of that module. So I can say declare module, and then I'll just use static KDTree, which is what we have. And then I can say that it exports a default function, which it does. And that function takes an array of numbers. So we'll call that points. It's a two-dimensional array of numbers. And it returns that KNN function. Actually returns more, but that's the only one I care about. Which takes a point, which is an array of numbers, and a k value, or the number of results that we want back, which is also a number. And it returns an array of numbers. So that array is actually an array of indices into the original grid of numbers. Okay, let's take a look over at Recommender again. And now I want to import that. So I want to import create KDTree from static KDTree, just like that. And now it's typed. So what I need to do now is create that two-dimensional array of all those points. So I'm going to go create a new function called GPU point, and it's going to take a GPU, and it's going to return that coordinate. So it's just going to be an array, and it'll take those coordinate values. So G2D, I think, was the first one, and then DX9 through DX12. And then also the overall speed, I think. Yep, that was it. And so now the next thing I want to do is create that tree. So let's go and use create KDTree to create a tree. And to do that, I just need to map over our GPUs that we got back and map that with GPU point. That's going to create an array of those GPU points. And now down here in Get Recommendations, I no longer want to do that slice. What I want to do instead is call tree and then KNN. And I need to give it a point. So I need to call that GPU point on the incoming GPU. Right? So that's the value from the selected GPU. Let's say we want 20 results. And we know we're going to get back a list of indices, which is not quite right. So we want to do a map there. So we do map again, and we're going to have an index coming back. And all we need to do is just say, hey, it's the GPU at that index. So let's take a look over here. Ah, awesome, cool. So React has done a hot refresh, and it's telling us that the closest match to a GeForce RTX 3070 is a GeForce RX 3070. No kidding. Really? Okay. But that's actually a really good validation of whether it's working or not. Essentially, we're basically saying the closest point to the point you gave is already in the tree. So we can just do a simple filter here where we get the ID from the result and we make sure that it's not equal to the GPU that we started with. Okay, let's take a look. There we go. Okay, so if I refresh this page, it now recommends as a first hit the RTX 2080 Ti, which I guess is right. Honestly, I'm a MacBook Pro person. I don't even know what graphics cards in my machine. I just think this is an interesting problem. And my daughter wanted one, so, you know, whatever. Okay, so that's really cool. I think that's just neat on its own. But what I think is actually even cooler is the fact that, I mean, think about it for a second. We can really give it any GPU, even one that actually doesn't exist within the data set. So we can actually model, I guess, a synthetic ideal GPU and have it come up with options that are close to what we want, which is a really interesting thing to think about. So I'm going to call that a synthetic system, and we're going to create a synthetic page that allows us to specify the GPU parameters that we want, and then it will tell us which GPUs actually match those parameters. Now, fair warning, this is actually going to be a lot of copy and paste code. I already have this code. I'm just going to kind of walk you through it again. It is just a little bit complex, so it's just a little bit easier to do it more in a copy paste style. So if you don't like that, I apologize, but I think that's the best for the time constraints of this particular video. And of course, all this code's on GitHub, so you can feel free to hack on it to your delight. Okay, so the first thing I need to do is I'm going to go over here and create a new route for our synthetic page. And we'll call this the synthetic page. And so we need to get that synthetic page from somewhere. And of course, we don't have it So we should go create it. So I'm going to start by bringing in React and some of the stuff we're going to need, like useState and useMemo. And then I'm going to define the synthetic page. And for the moment, let's just do return div hello. And for the moment, we just want to make sure that it's alive. So I'm going to go type in here synthetic. And there we go. Hello. Cool. Okay. So let's bring in a few more imports from the external libraries. I'm going to bring in make styles from Material UI and slider and grid. Slider is the little slider adjust bar, and grid is just a handy layout function. CLSX is an excellent class name manager for React. And then, of course, Formidable's awesome use swipeable. And then from our locals, I'm going to bring in the GPU type from GPUs, as well as the list of GPUs, those titles, the human readable titles, the comparison keys that we're going to use for the comparisons, and the get recommender that we built before, as well as the money formatter, so we can format the money when we want to show how much one of those really expensive video cards costs. And then we're going to go set up some styles. In Material UI, you do make styles, and that gives you back a new React hook. In this case, it's called use styles. And there's just a bunch of handy helpers here, like down arrow, up arrow, arrow, the comparison chart, which is a grid layout, the row item, and the product header. So now let's actually start on the component. So I'm going to start up here at the top and bring in a bunch of hook stuff. So we're going to create classes from use styles. We're going to have the recommended index. That's when you swipe left and right, which one you're actually looking at. And then the really important synthetic GPU. So this is a GPU, and we are actually going to give it the ID of 0, so it matches nothing. There's no ID of 0 in there. We're going to say that its price is 0, its name is synthetic GPU, and then we're going to give it the minimum values for all of the parameters. So we're going to have a minimum value and a maximum value. So let's go and build that. So that we only need to compute once. It's relative to the static data that we have, which is the GPUs. And the minimum maximum are just a map of the parameter, like G2D, to the number. So we go through each one of the comparison keys, G2D, DX9, so on and so forth, and we use a reduce on that. And that reduce starts off with an empty object, and then each pass through this reducer, it gets the new key. So G2D, DX9, so on and so forth. But it also gets the result from the previous pass, which would be that object. So we're going to turn all of the values from the previous pass, but also a new key for what we have on this pass, for example, with G2D, where we take the minimum value from the GPUs, where we do a map on that, and just grab out that key as a number. So this is going to return to us an array of all of the G2Ds for all of those GPUs, and then we just do a min on that. And the same thing over here, we do a max on that as well. So then we have a min and max lookup that gives us G2D min and G2D max. Okay, so the next thing I'm going to do is bring in the top of the page. This is going to be the set of sliders that are going to allow us to actually change the values. So let me just save that out. And so we can see up here at the top, we got synthetic GPU, and then we've got a list of sliders for all of the different parameters. And we can just kind of slide back and forth. So let's go take a look and see how that's done. So this is the header for synthetic GPU. And then we're just running through those comparison keys. Again, DX9, DX10, so on and so forth. We're creating a grid for each one and putting the title in there. And then within the second grid item, we're putting a slider. And that slider has the value as a number, as well as the range, min and max. And then whenever we get a change, we get the new value. And we just set the key to that value. And we take all the rest as the same. So pretty clean. So now we want to actually go and get the recommendations based on that synthetic GPU. So we'll use a nice use memo for that. Paste that in there. And now I've got our recommendations. So whenever a synthetic GPU changes, which is when we move those sliders, then we're creating a new set of recommendations by doing get recommendations with our synthetic GPU. It doesn't have to exist in our tree. All we've got to do is come up with a coordinate that has the values that we want, and it'll give us ones that exist nearby, which is really cool. So now we want to show those. So I'll bring in the code for that. And this takes a list of handlers. That's actually provided by the React swipeable library. So we need to go create those. Now, use swipeable comes from that formidable swipeable library. You get handlers for on swipe left, on swipe right. There's a whole bunch of them. And then you can also put in some settings. In this case, whether you want to track the mouse, whether you want to track the touch value, whatever. It's actually a really, really nice and elegant library. But it gives you back this list of handlers that you can then put on any kind of container. So in this case, I'm putting it on that div. And then within that, I've got our comparison chart. And then the top row is going to have an empty cell and then the name of the GPU. And then we're going to go iterate through those comparison keys one by one, showing G2D, DX9, so on and so forth. We show the titles for that and then what the value is. And down the bottom, we show the price. So let's hit save and see what we get. Oh, there you go. Nice. So the card that is essentially the worst, that has the minimum of all those values, is the poor little mobile Intel 965 Express. But by changing these parameters, we can see that we start to get different recommendations of cards that match that specification. In fact, actually, speed, because it's such a large value, is actually the predominant indicator here. That's one of the things you want to do when you use a mechanism like this, is make sure that all the scales are fairly right-sized and within, a similar distance, because what it's actually doing is a Euclidean distance measurement on this. But of course, you know me, I'm never going to leave it just at that. So what I've actually done is take the Pokemon data that we've used in a bunch of different videos and done exactly the same thing with it. So I can go over here and I can click on, for example, Charizard, and it will show me that the Gold Duck or Typhlosion Pokemon is basically exactly the same Pokemon in terms of its stats. And you can go and look to see what similar stats are to a Charizard. Let me show you how I did that over in the code. So the only real change was to go from GPUs.ts to Pokemon.ts. And then I changed around the interface to match the Pokemon data. The comparison keys I just moved from G2D to like hit points, attack, defense, special attack, special defense, and so on. I changed the title to be HP and so on. And then I went through and basically just changed the variable names throughout the project, but the actual core functionality, the logic, remains exactly the same. And that's really what I want you to think about when you think about using this example. So I provided both of these applications on GitHub, but I want you to think, hey, what are some things in my life that have a set of values attached to them that I have data on that I could go and use to either get comparison values? So given one thing, I want to see if there are other things like it, or given a specification of a thing, what are some things that match? For example, take housing as an example. If you've got some data on the number of bedrooms, the square footage, so on and so forth, the distance from the local elementary school or whatever, you can put all of that data into the system and then go and get out what matches your criteria or a house that matches your house. It's really cool stuff. I can't wait to see what you come up with. Let me know in the comments. All right, I hope you enjoyed that. I hope you learned a little bit about the KDTree algorithm and how you might use it in your context. Of course, if you like this video, just hit that like button. If you really like the video, hit the subscribe button and click on the bell, and you'll be notified the next time a new Blue Collar Coder comes out. This is the Wildwood Reserve, I think. It's a Bureau of Land Management area in Oregon near Mount Hood, an absolutely gorgeous area. And come out here every once in a while to do some filming. And boy, almost any point at which you put the camera, it's just so beautiful. I love it.